Good morning, good afternoon, or good evening, depending on when you're watching this. Now, what we're going to do is look at the laws of logarithms. I've written them along the top of the board. Log xy to base a is equal to log x to base a plus log y to base a. Now, I've written the proofs for all of them. I'm going to go through the proof for the first one with you and then leave you to work through the other two proofs. They're very similar. And like I always say, no one is going to ask you where they come from, but you absolutely have to know them and have to be able to use them. So let's look at the first one. They're saying here that if you've got log x to base a plus log y to base a, that is equal to the log of the product log xy to base a. So they start off in their proof by saying let log x to base a equal p and log y to base a equal q. Then what we did in the last lesson, remember, was you had to take it out of logarithms and be able to express it as a power. So log x to base a, I hope you're happy with, saying, well, x has to be equal to a to the power of p. And similarly, if log y to base a equals q, y must be equal to a to the power of q. That was last day's lesson. So if we multiply these, x times y, that's equal to a to the power of p times a to the power of q. Now we know with indices we can add these. So xy is equal to a to the power of p plus q. Now we're going to take it from indices back into logarithmic form. So again, linked to yesterday's lesson, we can say, well, if xy equals a to the power of p plus q, then log xy to base a is equal to p plus q. But remember, we said p was log x to base a, and q is log y to base a, so we can write these there, and that's your rule. So log xy to base a is equal to log x to base a plus log y to base a. Or writing it the other way around, if you have log x to base a plus log y to base a, that's equal to the product log xy to base a. So what would we do if we had log 2 to base 10 plus log 5 to base 10? Then that is equal to the product. If we are adding these, if we are adding these, then it's the product log 2 times 5 is 10 to base 10. So that you absolutely have to be able to do. Now similarly here, the second logarithmic law, log x divided by y, is equal to log x to base a minus log y to base a. Now it's a very similar proof and I've written it out there for you. What they're saying here then is log x to base a minus log y to base a is equal to log x divided by y to base a. For instance, if you had log 100 to base 10 minus log 10 to base 10, both base 10, that would be log 100 divided by 10 to base 10. 100 divided by 10 is 10, so log 10 to base 10. And the third logarithm law is that if you have log x to the power of n to base a, that's equal to n times log x to base a. Again, here's the proof, very similar. I've written it down, I've highlighted the important parts. So here we have, if you had log 10 to the power of 2 to base 10, what the third logarithm law is saying is that is equal to 2 log 10 to base 10. If you had 3 log 10 to base 10, the third logarithm law is saying that's equal to log, bringing that over here, 10 to the power of 3 to base 10. You have fractional powers as well, so log 100 to the power of a half to base 10 is equal to a half log 10 to base 10, or the other way round. If you have a half log 100 to base 10, that's equal to, bringing that back as a power, log 100 to the power of a half to base 10. So the rules are written in your textbook. I put an extra line here and there in to help you work your way through them. As in class, I don't like to saying this out of a hat, you're well able to follow it, but essentially what do you have to know at the end of this? You have to know these three logarithm laws. Log x plus log y is log xy. You have to know that log x minus y is log x divided by y, and you have to know that log x to the power of n to base a is n times log x to base a. So you have to have a working knowledge of those. You have to know what they are. They're not given in the formula sheet. You have to know them and you have to be able to use them. So let's do some examples. I have written them out again at the top of the page. Log x plus log y equals log xy. Log x minus log y, log x divided by y. And log x to the power of n is equal to n times log x. So let's do some examples. Remember as well We're going to make reference to this that we did in last day's lesson. This is used extensively. Log a to base a is equal to 1. So let's do these examples. We're going to simplify them using these laws of logarithms. So here, if we had log 2 plus log 8, we've got log x plus log y is equal to log xy. So we're going to multiply them. So that would be log 2 times 8 to base 4. Now that is equal to log 16 to base 4. Now I hope you would know that that is 2 because you would be looking at this and saying 16 is equal to 4 to what power? 4 to the power of 2. So it's equal to 2. But I'm going to write it another way to show you how we could look at the third logarithm law. I'm going to look at this 16 and ask myself, can I express that as a power of 4? And yes, you can. You could write it as log 4 to the power of 2 to base 4. And then using my third logarithm law here, log x to the power of n is n times log x to the power of a. So that would be 2 times log 4 to base 4. Now, really important, log a to base a is 1, so that's 2 times 1, which is equal to 2. But you could get the same answer here. Log 16 to base 4. 16 is 4 to what power? So it's 2. But I'm just showing you this so that you can see there's another way of using the logarithm laws. So that's straightforward. That's using that logarithm law there. Let's do the second one. Log 108 to base 3 minus log 4 to base 3. So that is equal to log 108 divided by 4 to base 3. So that is equal to log 27 to base 3. Now again, 27 is 3 to what power? It's 3 to the power of 3. Again, another way of doing it. Can I write 27 as a power of 3? Yes, I can. 27 is equal to 3 to the power of 3. And I know that I can then use my third logarithm law. 3 log 3 to base 3, which is 3 times 1, which is 3. So this whole thing simplifies to 3. And all I started by doing was using my second logarithm law. Now here you've got a combination, and that often happens too. So let's do the first part. Log 50 plus log 2. So that would be log 50 times 2. So I'm just going to write 100. Once you're well into working with these, you don't have to write it down like that. 50 times 2 is 100. So I've got log 100 to base 5 minus log 4 to base 5. Now that's my second logarithm law. So I'm going to write that as log 100 divided by 4 is 25. So 25 to base 5. Now like I said before, 25 is 5 to what power? 5 to the power of 2, so this is equal to 2, but we could write it as log 5 to the power of 2 to base 5 in our third logarithm law, 2 log 5 to base 5. And again, this thing here, log 5 to base 5 is 1, so that's 2 times 1. So that whole thing reduces to 2. So in these three examples, we've used all three logarithm laws. Now, number 4, I want to do this one with you to draw your attention to these. So if I've got, let me write this out here. If I had 3 log 2 to base 4, are you happy that that is using my third logarithm law? I could write that as log 2 to the power of 3 to base 4, which is log 8 to base 4. And this one here, that's a half log 25. So a half log 25 to base 4. I could use my third logarithm law again to write that as log 25 to the power of a half to base 4. Now 25 to the power of a half, remember 25 to the power of a half is the square root of 25, which is 5. So I could write that as log 5 to base 4. Now the reason I did that is here, if we do the first part, you would not just write log 20. You would not write log 20. Remember, to use this first logarithm law, it's log x to base a plus log y to base a. So you would have to change this first of all. You could not just say log 20 there. You have to deal with this first of all, and that's what we've done over there. So let me write in another line. If we had this, I would first of all write it as log 10 to base 4 plus log 2 to the power of 3 to base 4 minus log 25 to the power of a half to base 4. Now that's log 8. So that's log 10 plus log 8 to the base 4. So I'm going to use my first logarithmic law. That would be log 80 to base 4 minus log, now 25 to the power of a half is 5, so that would be 5 to base 4. Now I'm going to use my second logarithmic law, log 80 divided by 5 to the power of 4, which is equal to log 16 to the power of 4. Now again, I hope you're happy with 16 is equal to 4 to what power? 4 to the power of 2, so you know that that's 2. But another way of looking at it is log, can you take 16 and write it as a power of 4? Yes, you can. It's 4 to the power of 2. And using our third logarithm law, that would be 2 log 4 to base 4, 2 times 1, which is 2. But you could get that straight from there. Okay, now I'm just going to highlight this part here. Really important that you realise that you cannot just launch into your first logarithmic law. You would have to deal with these. Okay, thank you.